This is the last one, and I will give you a little quick review today, too, of what I expect to be able to do on the test. So today, we're talking about single and double displacement reactions. Single and double displacement. And after this, you'll be able to recognize. All you have to do is recognize. So, if something is displaced, what does that mean? Okay? It's what? Out of place. If something is displaced, it means that it's removed, right? Or it's taken out of place. So, for example, Charles, we're talking a displacement. Let's say I've got a calculator on the table, and I don't like it there, so I move it, but I put another one there. I've displaced it. Right? That would be a single displacement. I'm taking the position of something else, right? I'm removing something, like making a timetable change. Okay, so displacement means to move or to replace. Single, of course, means one. So single displacement means one thing is replaced. And by the looks of things, it looks like you got to do some writing there. So displacement means to move or to replace. Single means one. So single displacement means one thing is replaced. All right, all good? These involve reactions that involve an element and a compound. Single displacement involve elements and a compound. Compound is two things together, right? Like H2O, water. Hydrogen peroxide, H2O2. An element is a single element. So, in a single replacement reaction, a more active element replaces a less active element in the compound. So, in this picture down here, I'm just going to put it in the middle of the screen. Here I've got the blue and the red. That would be your compound, your two things together, your peanut butter and jelly sandwich. Plus, there's this black one here. The black one is more active. It has more, it's easier. The red element prefers the black one. Maybe your peanut butter and jelly gets the HEVO because peanut butter prefers to be with bananas.
You could easily make a girlfriend.
Peanut butter and apples? Okay. I like peanut butter and banana sandwiches myself.
Nutella and banana.
Peanut butter, yeah. Nutella and banana, that's a good one, yeah. Okay. Regardless, you can see here, what would you say? The black one has replaced the blue one, right? The black one has replaced the blue one. The black one is more active. Okay? If we go back to our high school dance analogy. Boy A and girl B are dancing. In walks boy C, who happens to wish to dance with girl B. If he's strong enough, he can push out boy A. Bullies him, says, get out of here. He wants to dance with girl B. Now boy A is all by himself.
Oh, that guy's so mean.
Yeah. Right? So the big guy here, he's more active. The girl prefers to dance with him. Okay, so in this case here, I don't even know what color that is. Pink shirt boy? Is that pink?
That's like, let's just
Salmon?
say that's white.
Salmon colored?
Peach.
Peach. Peach shirt boy has replaced blue shirt boy. Single displacement. Okay, what do you think would have happened if boy C wasn't strong enough to push out boy A?
Boy A beats up boy C.
Nothing. Nothing would have happened. The same goes with a single replacement reaction. If the element is not more chemically active than the element in the compound is trying to replace, No reaction will occur. And that activity, I'm not going to explain a whole lot. It has a lot to do with where they are on the periodic table. It has a lot to do with how their electrons are organized and stuff like that. That's something for down the road. Mr. Burnett can teach you.
Oh boy.
Okay? Generally, as you go across the periodic table from left to right, metals become less chemically active. So the most reactive ones are way over on the left, like lithium, sodium, potassium. Metal like that by itself is quite reactive.
So krypton is pretty good.
Krypton is completely inert. Those are the inert noble gases. They're quite happy to stay by themselves, and they don't react at all.
What's like the toughest, really?
The toughest, like you mean like the hardest?
Yeah, it's like
Probably titanium. Yeah. Like its density. A metal such as magnesium is more chemically active than the transition metals such as copper, tin, or zinc. An easier way to identify the activity element is to use an activity series which shows the chemical activity of both metals and non-metals. Not going to worry about that. Okay, so here are some examples. Okay, and back to the naming thing here. Pardon me? Mr. Bernard has the card. So if you've got magnesium and silver nitrate, and you get on the right-hand side, remember these are what's the left-hand side called? Reactants, and the right-hand side is called the products. What has been displaced here? The silver has been kicked out, right? The magnesium is the big bully. Kicked out silver. Magnesium should be sent to the office and given a stern talking to. Right? Magnesium has kicked out the silver. So this is an example of single displacement. Okay? If you were to do it as a skeleton equation, magnesium is what? Tiffany, follow along here. You're not, because you should be writing. That's how I know you're not. Magnesium is Mg, silver nitrate, AgNO3, kicks out the silver, so Ag is by itself, gives MgNO3, magnesium nitrate.
Are we supposed to balance?
Is that balanced?
Oh.
How can you tell? Say again?
There's not enough MGs and not enough O's on the left side.
I got one Mg. Let's just balance it here. Mg, Ag, N, and O. How many Mgs? One? One. How many Ags? One? One. So far, so good. How many Ns? Tiffany, how many Ns? Just one. How many N's over here? I got NO3, 2. So I got two of them, don't I? How many O's? 3. How many O's? 6. So I've got too much stuff over here. I need more over here. I need more O's and N's, right? So I'm going to have to put a 2 in front of that one, right? So that's going to make me 2 N's. It's going to make me 6 O's, but unfortunately it made me 2 AGs, right? So I got to put a 2 there. Now it is balanced. Single displacement. The Mg is taking the place of the Ag, right? See it? Okay. From the word equation, bromine plus calcium iodide gives you iodine plus calcium bromide. Is this single displacement? What's been kicked out? Iodine's been kicked out, right? Bromine as a formula would be what? It's one of those, oh no, it's not one of the diatomic gases. It's just Br. Sorry, it is a diatomic gas, right? It's a Br2. I don't think I ever really formally talked to you about the diatomic gases, did I? Diatomic gases are everything in group 7. F2, Cl2, Br2, I2, and AT. AT is hardly ever used. Okay? When they exist in nature, they are always doubled up. There's always two of them. That's why they're called diatomic. They have two atoms. Diatomic. Hydrogen's another one too. Hydrogen and oxygen as well. So bromine is Br2. Calcium iodide is CaI2. How come? Because Ca is a +2, right? Ca is a +2. Iodine's -1, so that's CaI2. Iodine is one other diatomic gas, CaBr2. What's the deal with the color coding here? What have I done? See how the Ca and the I2 are green? Here the Ca. Oh, actually the Br has kicked out the I here, hasn't it? Right?
Yeah. So really, you just know that it's kicked out that because it's closest to.
Well, here the I2 is bonded with the Ca. Here the I2 is by itself, right? So the I2 has been kicked out. You can tell by the words too, right?
Yeah.
It's been kicked out.
Are we gonna have to be able to do that? Pick the words and put the.
Well, you should. We did that in the first unit. I'll make sure that they're simple ones, right? And yeah, you should be able to do that. Like this one, you should have been able to do.
So how do we know to put that 2 there and 2 there?
Yeah, I'm gonna have to give you a list of all the diatomic gases on it.
Yeah.
Yes. I'll do that this period. You can write it on your periodic table. You remind me.
Yeah.
Okay, is this one balanced?
Yeah.
I got 2 Brs, 2 Brs. 1 Ca, 1 Ca, I2, I2. Balanced, right? Good to go. Okay, generically, you would have something like this. Z plus AB. Z plus AB gives you ZB plus A. Right? What's been kicked out here? The A is kicked out, right? The Z has taken the place of the A.
Do we have to say that?
You can say Z if you prefer. Here I've got Y plus AB. Here, what's been kicked out? The B. How come in this one, the Z is in front, and how come in this one, the Y is in the back? Well, it depends. Generally, metals displace metals, and non-metals displace non-metals. So like, because iodine is over on the right, it's a non-metal, right? So bromine, also on the right, this is a non-metal, bromine kicks out the iodine. Here, they're both metals, magnesium and silver, and magnesium takes the place of the silver. So metals kick out metals, non-metals kick out non-metals. Boys kick out boys, girls kick out girls, in the dance analogy. Okay? It's like a free agent signing. Now, this is a little dated, but when I first created this slide, LeBron was playing for Miami, and he wanted to go back to Cleveland. He displaced this guy, kicked him out, took his job. Can you think of any other celebrity analogies where someone has kicked out someone else and taken over their job? Could be sports analogies. Yeah, Donald Trump kicked out Barack Obama. That's true. That's a good one.
Scary.
Well, I won't get into that, but he certainly displaced him. Quick, man, I'm in the middle of a lesson. Gotta go. Full break. Okay. You know what, Charles? Can you wait? Like, this will take me like maybe 5 minutes because I need you to see this. What about double displacement? You guys ever play hopscotch and double dutch?
Yeah.
What does that mean?
2 things are replaced.
Double, right? Coffee and cream and sugar. Double displacement means to move or to replace. Double means 2. So double displacement means 2 things are replaced, not just one. 2 things are replaced. These involve reactions when two elements replace each other in compounds. Okay? They're sort of a switch. So you have two compounds, and they sort of trade partners. Trading dancers, exactly. In a double replacement reaction, two metal ions switch places. So I've color-coded these here. Which colors have switched? Tiffany, can you see the pictures there? Which colors have switched, traded places? All of them? Which ones have switched with each other? Like blue is with red here. Blue is with green here. Black is with green. Eh? Oh, does it look like yellow to you? Green. Green. So which two colors have switched places here?
Black and blue.
Black and blue? I think you're right. Right? The blue has gone into there, and the black has gone into there, right? The black and the blue have switched places. This is double displacement. Tiffany, don't worry about what color they are. Worry about learning this. That's what's important. Blue has bumped out the black, and the black's gone over here, right? To use our analogy of the dancers, two couples are dancing. The two girls look over and state that they wish to switch partners. Probably wise. Girls. I don't know. I don't know. At least salmon-colored shirt boy is left to dance. Apparently, he was a big bully, anyways, right?
I think he didn't even have a shirt.
Maybe it was just it was shirts and skins. That's why, yeah, hard to believe that the girl said okay, right? So here, the red shirt guy has kicked out the blue shirt guy. He goes over there and dances with the yellow shirt girl. Okay? This is called double displacement. Okay. Here's a hard one.
Oh my God.
Lead 2 nitrate plus potassium iodide gives you lead 2 iodide and potassium nitrate. So which things have switched? The iodide did. Lead 2 nitrate. So the lead is with the nitrate, right? But now the lead goes with the iodide, right? And the potassium does what? He goes over here, right? Lead 2 nitrate. Lead 2 means it's the lead with a 2 charge. Nitrate is on that polyatomic sheet that I gave you, NO3. It's a charge of -1, so you need 2 of them. Potassium iodide, K and I. PbI2 is lead 2 iodide. Lead 2 is a charge of 2. Iodide is a charge of 1, so that's why you need 2 iodines. KNO3, K is a +1, NO3 is a -1. Okay? And once again, you can see that the lead has kicked out, whoops, the lead has bumped out to K, right? They've switched places. Here I've got all blue, here I've got all green, here I've got blue, green, and green, blue, right? Double displacement. Generically, you've got a compound like AB plus XY. So this is compound 1, this is compound 2. What's going to kick out what here? A kicks out X. X goes, needs somewhere to go, so it jumps in with B, and you get AY plus XB. Does it matter what order these are in here? Like, could you go XB plus AY? Does it matter what order you write them in? No, it doesn't matter. You with me, Jesse? Everybody good? Say again?
We have to balance that because
No, this is not. Oh, this should be balanced though, I guess, right? Eh? Should we do it? Should we balance this? I think we're good with our balancing.
come on.
The biggest trade in hockey history. Where were you on August the 9th, 1988?
I was alive.
I know. I remember this day.
I was in my time machine.
I was working. I graduated high school. I was working, and I heard about it on the radio or something or other, and we were all in shock. Couldn't believe it. Wayne Gretzky traded. Is this double displacement? Is this an example of double displacement? Sure. These three guys, instead of playing with the Oilers, now these three kicked out these two, right? They switched teams. Double displacement. Right? Biggest trade in hockey history. None of these guys play anymore, I don't think. The end.